Okay. Yesterday we talked about Boyle and Charles and how, by the way, if you ever discover something, you name it after yourself or your science teacher. Anyways.
We'll give you credit.
Okay, thanks. Okay, so here's just a quick recap of yesterday. Boyle's law was about how if one thing goes up, the other must go down. Okay. I think of a seesaw. The name I need you guys to know for this, we call it an inverse relationship. I'll just highlight it. This is actually going to come up in math, believe it or not. There's actually a big overlap between how a graph is going to look. For those of you guys that do the 20-1 math, we're actually going to talk about that in a couple weeks. Sorry, I guess not for you guys as much, but I'll show you anyways. Charles' law, the word we use is it's a directly proportional relationship. So if one goes up, the other also goes up. Does that make sense? Well, I don't know who it was that figured this out, but someone realized that we can kind of take one law and the other law and kind of like merge them together. Hence the title, the combined gas law. This is really easy. This is the combined gas law. And maybe it even kind of makes sense. This little bit right here that I'm highlighting in blue was Boyle. And this little bit right here in purple, it's kind of cool, is what Charles' law was. Well, someone realized that we should just merge them together. And so we have what's called the combined gas law. This one's very, I don't want to say it's very easy because you still need to have algebra skills, but you'll know when to use the combined gas law because you're going to have a lot of numbers. Rather than being given like 3 or 2 numbers, when you get an equation that involves this, there'll be numbers everywhere. I only have one example. Look, 2 different volumes, 2 different temperatures, and the pressure. That's the giveaway that you have to use the big equation because we're talking about volumes and pressures and temperatures. We're going to use everything. Does that make sense? So, I wouldn't say that it's harder. It's just you got to have good algebra skills. But that's something that we work on in math. So here's the formula. A volume times a pressure over a temperature is equal to a volume times a pressure over a temperature. Oh my goodness. There. That's better. I think I flipped V and P around, didn't I? Doesn't matter. By the way, write this down somewhere later, right? So let's plug in what we know. A syringe is squeezed and compressed in from 150 to 65. So where's the 150 go? Yeah, this side here. And then the 65.0 is on this side here. Temperature. Temperature went from 21 to 23. So I put 21 right here and 23 right here. Yay, good. Good catch, guys. Waiting for that. Can't throw them in Celsius. It has to be in kelvins. So good catch that you guys noticed that. Okay, so 21 degrees Celsius is, what are you going to do? You're going to add 273. So what's that going to be? 294. And I guess that would make that 296. Quick side note while we're here. Going up by 2 degrees Celsius might seem like it's a fairly large amount on the Celsius scale because you're like, from 21 to 23, percentage-wise, that's a decent amount. But like on the Kelvin scale, if you're measuring everything back to like absolute 0 in theory where there's no heat whatsoever, the difference from 294 to 296 is like barely noticeable. You guys get what I'm trying to say there? Like if I were to give you a temperature of 5 degrees and 10 degrees, someone might argue that 10 degrees is twice as hot as 5 degrees. But that's not actually true. 10 degrees Celsius is not twice as hot as 5 degrees Celsius. It's actually barely hotter at all. Does that make sense? Because really we should be measuring on the Kelvin scale, and neither of them are. I think you get my point. So, all right, 294 Kelvin here, 296 Kelvin here. And the original pressure was 105 kPa. We're looking for pressure too. I'm a big believer that whenever you do math in chemistry, you should not just put numbers, you should put units down. this question was kind of nice because this milliliters and that milliliters and this Kelvin, they'll eventually cancel. But what if I gave you something in liters and another one in milliliters? Or what if I gave you kilopascals and millimeters of mercury? Does that make sense? So like, make sure you watch that your units cancel. So, last step, we just got to get P2 by itself. So, taught almost all of you math. Sorry, Zach. How do you get P2 by itself? Okay, multiply up the 296. 65, yeah. I mean, if you want to show what you're doing, technically you're timesing both sides by 296. That's what you're doing. And what's happening is this 296 here will then cancel. And you're also dividing both sides by 65. And you're dividing this side by 65. And then again, this side right here will cancel. Does that make sense? Okay, so pressure 2 is equal to this times this divided by these two numbers right here. I'll use my calculator in a second. I just want to show you that the units should cancel. And so the units that are left are kilopascals. I'd like to give some advice on how to put this in your calculator. I would recommend take the whole top of the fraction, put it in a bracket, then hit the divide by sign, and then put the whole bottom part of the fraction in the bracket. I'm going to show you what not to do. If you typed in this 296 times 150 times, is that a 105? That's a 105. And then you divide by 65.0 and then times by 294. If you type it in like I just typed it in there, it's not going to work. Do you guys know why? Yeah, what your calculator is assuming that you're asking it to do is it thinks it wants you to times the top three numbers, and then it thinks it wants you to divide by just 65, and then it actually wants you to multiply by 294. But we actually want the 294 to also be on the bottom. So don't type it in like this. My advice would be to put brackets around the bottom of the fraction. And brackets, oh, that's not right. Brackets around the top of the fraction. Because now what your calculator is interpreting this as is, it thinks put the whole top together, put the whole bottom together, and then divide the top and the bottom from each other. So this is what I got. 290, 243. Just get sig digs right. How many sig digs do I get? So round it up to 244. That's it. That's really all I've got to show you. Is it's just a law that combines the two formulas together. You'll recognize it almost instantly because there's just going to be so many numbers thrown at you. Like as I read this question, there's 5 numbers there. That'll be the giveaway for using this law. That's all. To be honest, I actually sometimes just write down this formula here rather than writing down this one and Boyle's law and Charles' law, because then if I ever need it, I just do what I kind of did right here where I say, well, Boyle's law is just the top times the top, and Charles' law is just the V over T portion. So really, the combined law might actually be like a better version of this law. It's just Boyle and Charles kind of came to their conclusions independently beforehand. Does that make sense? I'd say the hardest part about doing this is you just need to make sure you don't screw up your algebra skills. That's really where most of the work lies. Is make sure the numbers go in the right spot, and then you're going to have to do some sort of multiply or divide to isolate. So, right. I have another 6 questions right here. Do you guys want to kind of work on those independently and then do them as a group in a bit? Is that maybe the best way of doing this? Okay. By the way, I also gave everybody a worksheet that has lots of practice questions on it. That one's not for marks. That's just purely if you want more practice on this, I can give you practice. So, I don't know. Why don't I pause the recording? Why don't you guys take like the next 20 minutes-ish, maybe? Try these next 6 questions. Then when you're done the 6 questions, take a break. And then at I don't know. How about at like 10:02? I'll go over them. Does that work? So half an hour. So should give you about 20-something minutes to work. 5 minutes for a break. An extra 5 minutes in case, and then we'll go over them together. Awesome.